are a few aspects. Right. Okay. So there are a few aspects of this security in this pod that we can look at, right? First and foremost, to manage sensitive data into a pod, for example, like passwords, etc., Kubernetes provides this resource called a secret. A secret allows you to pass sensitive information into a pod. As you'll see afterwards, secret is not really secret. It is just base64 encoding of the data. And I'll show you, other ways of managing this secret. Okay, so that's one. The second one is that Kubernetes allows you to control how much resource a pod can consume. A badly written application, because you're running a cluster and the resources are generally shared across the cluster, a badly written application can actually take down the entire cluster, right? Because you'll just consume resource, and then it starves out all the other pods. What Kubernetes allows you to do is Kubernetes allows you to place some quotas and some limits on how much a pod can consume in terms of memory, in terms of CPU slices, and also how many pods can you create like in a particular namespace. Okay, so so it prevents this what we call the noisy neighbor type of scenario. Then the third aspect of the pod is the service level. The availability manages the service level, right? What is the service level of your application? For example, you can say that let's say if you're writing an application for a bank, for example, or a high trading platform, and then you want to say, I should manage my application should be able to manage 50 transactions per second, for example. And so that's a service level, right? So Kubernetes have different ways of managing this service level through replica set, through horizontal pod, horizontal HPA, horizontal pod, horizontal pod autoscaler. Sorry, afternoon. And also things like pod disruption budget. If you have to drop your service level, what is the acceptable level that you can drop? So Kubernetes provides all these resources. Kubernetes also allows you to create governance policies. For example, you can say, whenever a pod is deployed, the root file system should only be mounted as read only. So you don't allow people to willy-nilly go in and change the root file system or change the configuration, thereby changing the behavior of your pod. Okay, so that's pod security policy. You can also govern the control. What are the data coming in, or what are requests coming in, traffic coming into your pod, and also if the pod were to make egress, it means request out, where can it go to? So network policy controls that aspect. And then you can also set identity to your pod by creating service accounts. Service accounts restrict the what your pod can do. Okay, I'll talk more a bit about service account and user in a little bit. And then finally, you can also control the execution context of the pod. That is the environment in which the pod runs in. As you know, Kubernetes is based on Linux, and Linux, basically runs processes. Linux operating system, it runs processes. Execution context allows you to control the process running on a node, right? What it can do and cannot do. So we'll look at 4 aspects of it. We'll look at execution context, we'll look at secrets, we'll look at RBAC, and then we'll look at network policy. So the first one is execution context. Typically, we'll use execution context, to prevent elevation of privileges, so that bad things don't happen to the pod. Execution context defines what a container or what a process can do on a node. Because essentially, the node is a Linux node, right? So it's one of the design principles of security. Is the principle of least privilege. You give your container the least privilege, right? So there are 2 strategies in this scenario. Certain application, when you containerize them, can run as a separate user, a different user. For example, typically when you write a Node application or a Python application or a Java application, that application can run as a regular user, like user thread, etc. Certain applications cannot run as any other user except root, and that's just how they are written. Okay, so there are two ways of managing this. For applications that can run other than root, we will make them run as non-root, and for applications that must run as root, we will strip their privileges until we only give them the required number of the required set of capabilities for them to run. Okay, so I will show you these two examples, although the example is a little bit contrived. So let's go to our first demo. So what I'll do is this: I will first of all deploy an application, and then we'll look through the application to see what it can and cannot do. Okay. Oops. Okay. So what I'll do is this: I'll start off with the execution context. I've got a simple application here. This is a simple Node application. It's a fortune cookie, which I'll run afterwards. It's got a few properties. It's got a port, right? This is the external port, and then it's got an open weather map key here. Okay, in the first stage, I will not do the open weather map key, and I have got a Docker file which I've Dockerized it. Okay, I will talk more a little bit about this. So what I'm going to do now is I'm going to create a simple deployment and deploy this application so that you understand, the application. So before I do that, what I'll do is this: I'll create a namespace and put all this into a namespace. Oops, let me start. Okay. So what I'll do is this: I'll create a namespace. Okay, I'll create a namespace. I will call it workshop. Okay. Oops. Okay, let's have a look at. Let's have a look at this. So I've got. Oh, okay. So I spelled it incorrectly. Anyway, that doesn't matter. I'll just use that. Okay, workshop. So I'll create a deployment now. So it's apps v1, and the kind is a deployment. And we have the metadata. And then the name, I'll call this Fortune deploy. And the namespace, work SHP, right? So make sure that I don't put the wrong one. Okay, so the labels will just be this guy here. Okay, and then we'll create a spec for this application. I'm going to create one replica. Okay, I'm going to create one replica, and we have a selector. So the selector here is to select the port, okay, the port's label, okay, which we have not created yet. I'm going to call it. I've got a naming convention which I follow. So fortune port, I'll call it port, and then we'll create a template. We'll call it name, template metadata, and then the name will be this name, and then the labels will be this label. Okay, so just a quick Kubernetes 101. The selector here, okay, the selector here matches this label, and then we'll have the spec for the template, and then we have containers. We have the name of the container, which I'll call Fortune container. The image, so the image is this guy, right? This guy, which I've already created the image for, and I push it up to Docker Hub. Okay, so the image is v2, version 2, and then the image pool policy, if not present. So we only want it to pull if it's not present. And then we will set the environment variable. So again, this environment, we're going to set the port. Okay, so this environment variable here. We'll call it port. And then the value will be, let's put it 5,000. Okay. And we need to define the pods section. And then we just go container pod, which is 5,000. Okay, so that's roughly the deployment. So let's run this guy. So I'll run this. Replicas. Okay, so that's running. So let's go and have a look at this. So let me do this. You can create a watch cube. CPL. Get PO is the pod, and then we go deploy. We want to look at workshop space ORK, that's HP, right? Okay, so it's up and running. So I've got one deployment and one pod. So let's just try looking at the application first before we go and examine the pod. Okay. So I will do a pod forward. Remember, this is a deployment, right? There is no external. There are no external traffic coming in. So I'll just do a pod forward to test my application. Kubectl pod forward. I'm going to forward to the deployment. So the deploy is Fortune deploy. And then the namespace is workshop. I'm going to pod map to 8080 to 5,000, right? So that the left hand side, the 8080 is the external pod, the 5,000 is the container pod. Okay. So let's run this. Let's have a look at this application. So we go localhost 5,000 and oops. Oh no, it's not 5,000. It's 8080. Okay, right. So this is the application. So it's very simple application. It's just fortune cookie. Fortune cookie is like, you know, the American food. If you go get American food, there's after the dinner, you know, you get this fortune cookie, you break it up, you know, there's this paper, right? Okay, so there's this fortune cookie, right? So we have got a pod running, this pod, right? So we can now actually go into the pod and have a look at the pod, okay? By doing exec into the pod. We go kubectl, we exec, we create a pseudo, we allocate a TTY and make it interactive, and then we tell it this is the pod, and then we say it is workshop, and then I'll start a shell. Okay, so I'm now inside the pod. So I'm now inside this this pod. I'm inside the container. That's my application. And the first thing you'll notice is this: if I type ID, you notice that it is actually run as root. Okay, and the files belongs to root. Okay, so this is immediately, you know, if anybody get access to it, they can just access in and they can do whatever they like now, right? So this is a really simple application, right? What I can do is this, right? I can just delete everything here. So my entire application is deleted, right? So now if I run this, right, the application will crash because, you know, it is no longer available, right? Or in a worst case scenario, imagine that you have some configuration files inside here with some, with some configuration, and the user can actually come in and change the configuration, right? Because when you exec in, you get root permission, so you can change the configuration, and then it will totally change the behavior of your application. Okay, so what we're going to do now is this, right? So there are a few ways we can manage this. Let me delete that one first. Okay, I'll delete the pod first. Okay, so there are a few ways you can do this, right? The first way is to make the container run as non-root. Okay, so what you need to do is this: you need to go to the Docker file, and generally the way people do it is like this: you do a user add, and you add a user using a Linux command. So whatever user you want, and then you go user. Let's say you add Fred, right? So you go. There are some properties here which I have to look up. I can't remember. You have to say, then you say user Fred here. So when you do that, then this container will run as user Fred. Okay, but more often than not, right? You may not have access to the container, to this Docker file, because somebody has built the Docker file, and you're just using it, right? So you don't have access, to this Docker file. So as a deployment, so if you don't have access to this, what you can do is this: you can make sure that when the container runs, it is run as non-root. Okay, and the way to do that is like this: inside this deployment, under spec here, okay, you create an attribute called security context. Okay, so now you can say run with whatever user you want. So you can say run as user, right? Whatever user. And generally, in Linux, you will notice that. So this is Linux. You know, and this is the user ID, and I think this is the group ID. You notice that in general, users actually start So this is my user. Users actually start at 1,000. Okay, so anything after 1,000 is okay. So what you can do is this: you can say run as user, and let's run it at 5,000. Okay. Optionally, you can also specify a group if you want to. Okay, so maybe the group, let's say group 1,000. Okay, so now I'm getting the container to run at as a non-root, and we'll do the same thing again. We'll now apply, and let's start again. Okay, so now we will go in to the pod again. Okay, so notice now it's different. Just now you see a root here. Notice now this is different. And if you type ID, you'll notice that the user ID is 5,000 and the group ID is the group ID is 1,000. That's a group ID. And the really nice thing about this is this: the files are owned by root. So if you try to change it, it won't work because we don't have permission. Okay, so this is one way of doing it. This is for containers that can run as non-root. Okay, not all containers can run as non-root. So it really depends on the application, and you need to understand the application. For containers that cannot run as non-root, what you can do is this: you can restrict their capability. Okay, and the way to do that is through something in Linux called capabilities. In Linux, there are a lot of different capabilities. For example, like creating file systems, opening port, etc. Right? And they are grouped under different capability, capability group, for example. And the way to look at capability group, at least in Linux, is to do this. So let's look at the capability, the capability of this particular process, right? And the way you look at it is you go to you do a grep cap on the proc. You get the process ID of your current process, and then you type status, right? So this is the capability here. This is the inherited capability. Capability is actually pretty complex, right? So this is the inherited capability, and this is the effective. This is what is permitted. There's no permitted capability, and this is what is effective. Okay, so essentially this guy here doesn't have any effective capability. So let me just very quickly revert back to root first and show you what are the root capabilities. So I will delete this guy. Okay, and let's just delete this one, and let me deploy again, and I'll show you the root capability. Okay, so we'll do the grep again. So this is now root. So we'll do the grep again. Grep of the cap proc $bash PID. the $PID is the current process ID of this process of the container. And then we'll look at status. So notice now that this is the capability what we want is we want the effective capability, which is this guy. So you can copy this guy. And what we can do is that we can decode it. If you're running on Linux, the way to decode it is you go cap shell, decode. Do that. So this is the capability. So we can change own discretionary access control override. Some file owner stuff and things like that. The net ID, etc. So let me show you one thing, and then I will show you what we can do with it. So in this case, for example, right? Let's say I do a ping, right? Let's say I can do a ping of let's say Facebook.com, right? Okay. So what I'm going to try to do is this, right? I'm going to try to shut off this capability, remove this capability from my container. Okay. So again, remember that these are all the capabilities of my root container. So I'll exit this guy, and what I'll do is this: I'll kill the container, delete the container, and the way you do a capability is like this: under the containers. So no longer under the spec here, under each individual container, because remember, each individual container is a process. We need to constrain the capability of that process. So you need to define this in the containers. You do the same thing again. You do security context. Okay, and then you say you can do either drop, okay, or add. Okay, so what I'm going to do is this, right? So let's say, for example, this application needs to run as the user root, but it does not need any other capability, right? So I can just do like this. I can say all. That means drop all, right? If I want to retain, I want to give it the ability to ping. Okay, so I can say add. Okay, so the ability to ping is you can find this out. So this is the ability to ping net raw. This guy, this ability, this is the ability. Okay, cap net raw. So you can say drop everything except the net raw. Okay, so when you type this, when you add this capability, make sure it's in uppercase. First point. Second point is drop the CAP, the cap in front. Okay, or this cap in front. Just drop that. Okay, so I drop all capabilities except net raw. So now let's deploy this guy again. Oops. Hang on. Okay, so let me check the documentation first. Drop container. Container here. So this is container security context. Capabilities. Oh, I didn't put capabilities. Okay. Capabilities. Okay. Right. Okay. So let's look at it again. So let's look at. Okay. So we're running this again. So let's go in now and have a look. Okay, so we'll look at the capabilities again. We'll go grab cat proc.bash PID status. Okay, so notice now the capability is different, and this so this we need to look at the effective one. So this guy. So what is this? So everything else is different. So remember, this is our previous one, right? So now we only have this capability, which is net raw, and then we can do a ping of Facebook. microsoft.com, but nothing else. Okay, so this is one example where you can, if your container needs root to run, you want to constrain how much capability it has. Okay, one example of this is actually Nginx. If you're deploying Nginx, Nginx needs to run as root. You cannot run it as any other user. So in that case, you can go into the container and customize it. Make sure that it only requires you only give it the capability that it requires to run. Okay. Okay, so that's the end of the first section, which is execution context. Okay, so we'll look at the second part of this talk, which is secrets. As you probably know, most of our modern application, sort of follow the 12-factor app prescribed way of building application, at least application that scales horizontally, right? Sort of follows the 12-factor way of developing and deploying application. And one of the factors, actually two of the factors, states that you should actually externalize your dependencies, and you should also externalize your configurations. Okay, so it makes sense, right? So dependencies is because most of our application requires some sort of library, and if you're writing Java application, you have a Gradle file or your form file. In the case of Maven, Python, you have requirements file. Node.js, JavaScript, you have your package, right? So you externalize the dependency. You also want to externalize your configuration. For example, like what is the database to use? What is the database password, etc., etc., etc. Okay, so those are the two things that we externalize. So one of the things, so when we externalize our database information, right? Like our API keys, our password, etc. Kubernetes gives you two ways of creating configurations. Okay, the first way is something called a config map. A config map is a resource which is just key value pairs, right? Like if you have done Java, it's just like your .properties file. Okay, it's just key value pair, and they are in plain text. Then the second way, which is called a secret. A secret is also like a config map, a key value pair, except that in secrets, the value is encoded as base 64. Okay, the idea is this: secrets is used to store your sensitive information. So we do not want casual browsing. So we do not want your coworker to walk past the screen and happen to see your password, right? So base 64 makes it slightly more secure, right? But not really that much secure. Okay. So one thing to understand is that base 64 is encoding, right? It's not encryption. Okay. So it's neither safe nor secure. And the other thing really bad about secrets is that you cannot check it into your repository. Okay, because it's base 64, anybody that has access to your repository can just unbase 64 and can just unbase 64 it. There are many alternatives to this problem. If you are deploying to Azure or AWS or GCP, then they've got integration with their KMS system, their key management system, right? Or if you're your own organization, your enterprise, you can deploy a full-blown KMS like HashiCorp's Vault. But those requires a lot of resources and also requires a lot of expertise to manage them. So a simpler example, if you are a single developer, a more secure example, besides a full-blown KMS, a more how should I say, a really good resource to use is something called sealed secrets. Okay, so we'll look at it. It's not default in Kubernetes, but I'll show you how to use it. So before we do that, we are going to do a demo of this. So what I'm going to do is this: we'll proceed to the next stage of our application. So this is the first stage. So we'll go to the second stage. let me just. Okay, so let me do this again, right? So in my fortune cookie application, there is actually a weather. Okay, there's actually weather. If you put in the weather key, the weather key, the API, it will show you the weather. Okay, and what I'm going to do is this. Okay, so let me delete the application first. So let me copy the file over. Let me copy the file over. Okay, so let me copy the file over and let me delete the application first. Okay. So, right. So, so what I'm going to do is this, right? I'm going to set the API key as a secret, right? So that when I deploy the application, you'll get to see the weather. The application will detect that it has a key, then you show the weather, right? And I'm using the open weather map. So let me show you the open weather map. So this is my open weather map account, and this is my API key. So I'm not afraid of showing you because I'm going to delete this afterwards. So this is my API key, right? So what I'm going to do is this. I'm going to use this to create a regular, just a regular secret first, right? And then I'll inject the secret into my application and then run this as what we generally do. Okay. So what I'll do is this. I will create a file called secret. Okay. And then the kind is secret. And then the metadata. Yeah, so I'm going to copy from here. Okay, and then I'll say data. Okay, so this is my secret. And then the key is, because remember it's a key value pair, API key. Okay, so this is the information, this is my key, right? So this key, that there are two ways to create secret, right? One way is to use the data, and then this thing has to be base 64. Okay, so what we need to do is this. We need to do this base. We need to do this. We need to echo base 64. Okay, so this is the base 64 key. Okay, so this is one way of doing it. If you do not want to base 64, then you use something called a string data. Okay, and you can use any key again, API key, for example. Okay, so you can either pick one of these two. If you have two, I cannot remember the precedence. I think the precedence is for string data, right? So we're going to use this this key here, this the base 64 encoded one. Okay, so I will now deploy this guy. Okay, so let's make sure that we got the secrets deployed. Okay, so we've got the secrets deployed. You can actually look at the secrets, right? So it's actually not really like a secret. You can look at the secret by just going kubectl get secret. So the the name of the secret, which is fortune secret. You can look at the file YAML, right? And oops, -n workshop. Okay, so you can look at the secrets. So here, so you can see this secret here. So if you copy this guy, and then you go echo base 64 minus d decoded, you get back the key. Okay, so this is the key. So it's base 64. This. So how do we use this? So the way we use this is we go back to fortune here, right? So this is my application. Now I'm going to use the secret, which I will put here. I'm going to add it as an environment variable. So the environment variable needs to match this guy, right? Open variable map. Okay, so the value, so we say, instead of saying value now, we say value from. Let me move this up. Okay. So value from, okay, so secret, secret key ref. Okay, so the name of the key is fortune secret. And then the key name is API key. Check. Okay, so API key, right? So this is the key. Okay, so we are injecting the secret into the environment variable. When Kubernetes injects it, it base64 it. So we get the proper key back again, right? So now let's deploy this guy. Let's make sure that it's deployed. Okay. So now we will do a port forward again. So we'll do a port forward. Oops. We'll do a port forward again. Okay. And now if we run, if we reload this guy, now you notice that this is the secret that's coming. Is using the open weather map secret to get the data to get this information. Okay. So there's a few problems, right? The first problem is this: if you forget to git ignore the file, the secrets will get checked into your repository. Okay. So this thing will get checked into the repository, and you do not want this to be inside the repository. Remember, this is just a simple, simple API key. You have other more important things like your database credentials, etc. Right? Your SSO token, etc. Right? So all this will be a problem if you don't protect it. Okay, and so really secrets is not really that great. Okay, so what we want to do is this, right? We want to use so you can use if you are on AWS or whatever, you can use their KMS system, and their Kubernetes integrates with their KMS. So you can get all this to be managed by their KMS. But as a single developer, for example, and you want something cheap and really relatively easy and secure, you can use something called sealed secrets. Okay, and the way sealed secret works is like this. Okay, sealed secret is a custom resource, and the guys who did it is actually Bitnami. So you can look at sealed secret. Sealed secret consists of two parts. Okay, sealed secret consists of two parts. You go to release. It consists of two parts. The first part is actually a command line tool, okay, called kubeseal. Okay, the second one is a custom resource that you deploy to your Kubernetes cluster. I've already deployed it, so you can just copy this and deploy to your Kubernetes cluster. And so this will run. This will run the. This will create some resources, some sealed secret resources inside your Kubernetes cluster. And the way you check it is you go kubectl get po -n kube system. You should be able to see them here, like this sealed secret controller running. Okay. So the way it works, so once you have deployed that, right, and the way it works is like this. You have created your secret. Then what you do is this: you run your secret through the kubeseal command, the CLI. Okay, and what that will do is this: that will generate a YAML file. This YAML file will contain your secret, but it is now signed by the sealed secret controller. It has got a pair of keys that will actually encrypt this. So once this is encrypted, right, you can actually delete this file, your secret file. Okay. Now this is actually safe to be checked into your GitHub, because if anyone who doesn't have the key will not be able to access the secret, right? So now what you do is this: when you want to deploy your application, you take this file, and then you just use kubectl to deploy it into your cluster. When you deploy into your cluster, the sealed secret controller will notice that, oh, there is a sealed secret resource that is being deployed. What you'll do is this: you'll use its private key to unseal, to unwrap the secret and convert it into a regular secret inside your cluster. Okay, then you can deploy your pod. Your pod can look at the secret. So notice this part here is still secure, it's still safe, because you can save this, right? But if anybody has access to your cluster, they can look at the secrets because it's still there, right? So we'll address this a little bit later on, but we'll look at this part first. Okay, so let's see how we do this, and it's actually quite simple. Before I do that, I want to also delete this secret. So let me just go back here and I'll delete this secret. Okay, so I want to clear everything. Okay, I also need to delete the fortune. Okay, so I've deleted everything. And what is going to happen now is this. The secret, we will use the kube seal. Okay, so you cannot use kube seal until you have deployed the sealed secret controller, because kube seal actually talks to the controller to get it to sign your secret for you, right? So your kube seal, you want to save it, so you go, I want output as YAML, and then you pass in your secret. Okay, and then you save it to something. Like that. Okay, so you go seal secret. Okay, output as YAML, because this is YAML. Give your secret file, and then output that. Okay, so now we can actually look at the sealed secret. So this is the sealed secret. This is the thing that has been signed by the controller. Okay, and this is the original secret. So what we will do now is this: we are now going to deploy this. Okay, so notice that I do not have the secret, right? I'm only going to deploy the sealed secret. Also, by the way, when you deploy the sealed secret, it has a custom resource called sealed secret, which you can look at. Okay, so what I'm going to do now is this: I'm going to deploy this kube cuttle apply -f fortune sealed secret. Okay, so notice that what's going to happen is this: it will create a sealed secret, and then the controller will unwrap the sealed secret and deploy the secret here, right? So we can actually look at this guy now. Okay, so this is the secret. This is the original secret that's being deployed. And this is as before, right? Okay, so the nice thing is that if I now delete the sealed secret, okay, it will delete this, and it will also delete my secret for me. Okay, so now I don't need, so once I've got sealed secret, I no longer need this guy, so I can actually delete this secret. Okay, so I'm left with just my sealed secret and my fortune, and I'll deploy it again. Okay, and I will also deploy the fortune application. Okay, and just to make sure that it works, you port forward again. So now, so notice that it's continuing to use that, right? So I only just discovered sealed secret recently, and I really like sealed secret. So you can actually use this, right? And one way to do this is this: you can actually back up. The issue is this, right? If you delete the sealed secret resource, you will lose the public and private key. I mean, the certificate and private key within a seal secret. So what you can do is this, right? If you're planning to use this, right, you should probably back up the two certificates. And the way to do that is to go to kubectl get secret, okay, from the kube namespace, kube system namespace. Okay, so we want to grab the TLS. Just do that again. We want to grab the TLS secret. So this is the seal secret, is a Kubernetes TLS secret. We can grab the file by getting the YAML file. Okay, so let's have a look at this guy. So these are the two. Oops. Let me try it again. Okay, so this is my. Okay, so I want the. Sorry, let me do that again. I need to get the name. Get this name. Okay, so what I'm going to do is this. Paste this here, and I want the YAML output for the seal secret. The reason is because I want the two certificates. So this is the key, okay, and this is the certificate. So let's back this one up. Okay, and let me move this thing into O2. Okay, so we can now examine it. Okay, so this is the seal secret. We can recover it, right? So I'll just show you. We can recover. This is the X509 certificate. We'll recover it by just doing 509. I want to grab the certificate. Oops. Sorry. Okay, so this is the certificate. We can actually base 64 decode it, right? So we can go base 64 minus D, okay, and we can look at it. Okay, so let's run this guy. Oh, bash, sorry, bin bash. Okay, so let's run this guy. Okay, so notice this is a certificate. Okay, so we can output the certificate. So we can say seal certificate cert file, and then we can look at the cert file, the SS cert file, by going open SSL X509 in the SS cert, and then we want no out and text. Yes. So this is the certificate that is used to sign. Okay, so you can back up the two files. All you need to do is just grab the seal secret YAML file, right? So this, you need the certificate and the key, right? Base 64 them, get the key. So the next time when you deploy them, just recreate this configuration again, and you get back the same key. So you can reproduce, this certificate. Or if you want to, if you don't trust this, you can use your own key and you can use your own key, right? Or use OpenSSL to generate a key pair, right? And then sign it, get somebody to sign it, your X509 whatever, and then deploy that as a TLS secret into Kubernetes and get seal secret to use this, right? So this is actually very simple, relatively easy, do not have a lot of overhead, and it's very easy to use. Once you know OpenSSL, you can actually use this. Okay. So that's the second part of the presentation. So we are left with the next thing I'm going to talk about is something called role-based access control, or RBAC. What RBAC does is it gives users and service account. You create roles for users and service account. in Kubernetes, there are two types of subjects. Okay, there is the service account, and then there is the user. Service accounts are essentially subjects, security subjects that are managed by Kubernetes. They're managed by the Kubernetes cluster. And typically, we will use service accounts on things like pods. We want to restrict, a pod, right? Your pod will only need service account if your pod interacts with Kubernetes. For example, so far, Fortune doesn't actually interact with Kubernetes resource. So I'm just quite happy to use the default service account. Every time when you deploy an application, Kubernetes, creates a default service account for you, and that service account doesn't have any, permission to do anything. Okay, and that's perfectly fine if your application is not interacting with Kubernetes. So what do you mean by interacting with Kubernetes? Interacting with Kubernetes means basically calling the Kubernetes API server and getting information from it, like, what is the namespace that I'm currently in, creating more pods, etc., etc. Okay, so we are interacting with Kubernetes. So that's the first one. And service accounts, right, are managed by Kubernetes, and they use tokens. They use bearer tokens for access. So bearer token, right? Most of the API, most of our HTTP API use, right? You have HTTP header, and the way you use it is you use the HTTP header. In the HTTP header, you got authorization, right? And then you got bearer, and then you have the token. And generally, the token is JWT. Okay, so that's service account. The second type of security subjects are users. Users are strictly not managed by Kubernetes. Okay, they represent people, person. And the way Kubernetes recognizes a user is through a signed certificate. So this certificate must be signed by Kubernetes. So if you have a Kubernetes certificate that's signed by Kubernetes, then Kubernetes will recognize this. So in other words, the user actually doesn't reside in Kubernetes, but so long as you present a certificate that Kubernetes recognizes, Kubernetes will allow you through. Okay, so that's the second group. So what we want to do here is this, right? We want to use role-based access control to define the minimum number, the least privilege, for a user or for a pod to perform its work. Okay, so remember, right? There's a distinction between what we see execution context and service accounts. Okay, execution context is when the pod is running as a process on the node, so on the Linux node, right? So the execution context is essentially Linux security. Okay, service account, it doesn't deal with Linux, it deals with Kubernetes resources. Okay, so making HTTP calls, making resource calls to your API server and performing things. Okay, so there are two sort of separate things, right? So what we're going to do is this. The scenario we want to do is this. We want to create a user. So we now have a namespace called workshop, and we want to create a user, and we want to allow the user to only be able to look at pods and deployments and nothing else. So we do not want the user to be able to look at like the secrets or the skill secrets, right? So in this case, just now here, we can actually look at the secrets here, right? And we can read the secrets, right? So maybe we do not want that. We only want to create a user to only look at these two, just for monitoring purposes. Okay. So before I jump into that, let me briefly explain how RBAC, role-based access control, works in Kubernetes. Kubernetes has resources, and there are two categories of resources. There are what we call cluster-wide resource. In other words, resources that are not scoped to a particular namespace. Okay, so these will be things like certificates we shall see afterwards. And then there are resources that are scoped to a particular namespace, like pods, for example. volumes, secrets, they are scoped to a namespace. So you have scope resources and you have cluster-wide resources. Okay, so those are the two categories. And then for each one of these resources, you have a list of actions. Okay, you have things like create, get, update, delete collection, watch, etc. Okay, and what you want to do is this. A role is basically a name, any name that you give, plus a set of resources and a set of verbs, a set of actions, right? So if it's an administrator role and I want it to only view my deployment and pods, then I would say, this role can have access to pods and deployments, and they can only use the get, the list, and the watch verbs. So that's a role. Okay, so you define a role, and then you define a subject. A subject, as I said just now, can be a user, can be a service account. So we have subjects and we have roles, and then you need to bind them together. You need to create a binding. Okay, so this is called role binding. Okay, role bindings. There are two types of role bindings. There's the cluster role binding, which you bind subjects to cluster-wide resources, or you have just your regular role binding. Okay, so in this particular demo, the next demo that we're going to do, we're going to create a administrator that can only look at pods and deployments in our workshop namespace and nowhere else. Okay, and service accounts is actually quite easy, and there are many examples of it. So I will not do service account. I'll create a user. Okay. So so the next thing what we don't do is this. I'm going to create a role to only monitor pods in the workshop namespace, right? And so the first thing we'll do is we'll create a user, and then we'll assign some roles. We'll create some roles and we assign it to the user. Okay, so what I'll do is this. I will go to O3. Okay, so as I said just now, right, for users, it's not something that is intrinsic in Kubernetes, like a service account, right? So what we need to do for users is we need to create a certificate for Kubernetes to sign. Okay, so the first thing we'll do is this. We will create a certificate. We'll use open SSL. We'll create an RSA certificate, and I'm going to save it to a file called thread.key, right? Okay, I'll use the default key size, which is 2048. So this is my key. Okay, so now I need to create. So that's my key. Now I need to create a certificate signing request for Kubernetes to sign. So I will say request. I'm going to create a new request, and the key is the thread key. Okay, the output I'm going to write it to. This is my signing request. Okay, and this is the important one, the subject line. Okay, this is the name of the certificate. Okay, so as you probably know, if you are requesting a certificate for a website, then you put your domain, fully qualified domain name website, right? So in here, I'm going to put the name of the user, so to speak, right? So I'm going to call this user Fred. Okay. So like this, so I'll create a certificate request. That's the key I've generated. This is the signing request, and that's the name. Oops. Out. Okay. So we can look at the CSR, the signing request, by doing request, open SSL, request. We'll put in thread CSR. Okay. So this is the CSR request. Okay, so the name, so this is the important one. We need to remember this. Okay, so the common name, the algorithms, etc. Okay, so just to check that. So now what we need to do is this. We need to create a signing request for Kubernetes to sign. So, okay, we need to create one of these guys. Okay, a certificate signing request. So we'll call it thread CSR. Okay. So the API version is this guy, certificates. Okay, the kind is certificate signing request right up here. Okay, and then the metadata. Okay, I'll call it thread CSR. The certificate signing request is a global resource, so it's not bound by namespace. So the next thing we need to do is this. We need to have the spec. Okay, so there are quite a few things here. The only thing we need is three things. We need the request, which is the X509 certificate. We need the sign. We need the usage. How are we going to use it? And we need the signer name. Okay, so let's start with the signer name. Inside the Kubernetes cluster, there are a lot of CAs, different CAs. Okay, so there is the Kube client API. There is the Kube server API for kubelet, and then there's a serving, etc. So you read through all this. The one, since we are going to access the Kubernetes API server, we are going to need this CA. We're going to use this CA to sign. Okay, so that's the signer name. So we will say SI signer name. So that's my signer name. The second thing I'm going to need is what am I going to use it for? Usages. So it's an array. We should do this. There are many things. I want to do client authentication, so I will have client auth. Okay, you can have other things, but that's enough for me. You don't want to give too much, right? And then the third one is the actual certificate CSR itself, okay, which is request. So the request has to be base 64 encoded. Okay, so this is what I'm going to do. Let me show you what you do. So we need to take your CSR, right? So this is the CSR. Okay, first of all, we need to base 64 encode it. Okay, and then we need to convert it into one long string. So let me do that again. So this one, okay, so this like this. So we need to convert into one long string by stripping out the new line by doing a tr minus d like that. Okay, so we strip it out to get one long line. Okay, paste it. Yeah. So we will do that by doing this. Cat thread CSR base 64 tr minus d. And we want to do that. Okay. So this is the CSR, certificate sign request. And now we ask Kubernetes to sign this. Okay. This is our CA. Sign this for me. And we just use a kubectl. Okay. So we can have a look at it by doing this. Let me stop this guy. Okay, we can have a look at it by doing this. Go kubectl CSR. You do not need namespace because it's global. Okay, so notice I've got one. The condition is pending. So this is the name of the requester. So I'm going to get this guy to sign. That's my CSR, and the condition is pending. Okay, so now to sign it, right? You use the kubectl certificate. Okay, so you say kubectl certificate. Okay, so we want to approve. So be careful, Once you approve, you can no longer deny it. Okay, so the only way, once you've approved, the only way to deny is to delete the certificate and resubmit for approval. So something has been approved or denied, you cannot change the status. So I'm going to approve thread CSR. So notice the condition is currently pending. Okay, so that's been approved. So let's look at it again. So now notice that it is approved and issued. Okay. Sometimes if you type something here incorrectly, especially in the usages, something that it doesn't understand, what you see sometimes is this: after you've approved, you see approved, but you don't have issue. So if you don't see this line, right, this term here, right, it means that it's not issued. It means there's something wrong with your CSR. Okay. So now that it's been issued, I need to get my certificate. And the way to get my certificate is like this: go kubectl, get CSR, the thread CSR, right? Okay. So what we need to do is this: we need to go JSON path. You use the JSON path notation, status, certificate. Okay, like this. So this is the certificate. And what I'm going to do is this: we will base 64 this. This is in base 64. We'll decode this. And you'll notice that this is the certificate. Okay, so I'm going to save it. Let me clear this one and do it again up here. So I'm going to save this to a file called thread cert. Okay, so this is my request CSR. This is the actual cert that's been signed. Okay, so we can have a look at the cert by going open SSL X509 in thread cert. No text. Yes. Okay. So notice that the issuer is the minikube CA. Okay, and the subject thread is this. So now that has been signed. So I can now use this certificate, right? So I have got my key and my certificate. Okay, and the way to use it is this: you need to, as you probably know, every time when you interact with Kubernetes, you've got this thing called a kube config. Okay, so we will go to the kube config. In the kube config is saved in the .kube directory in your home directory. Here, this config file. Let me make a copy of it first so I don't mess it up. Okay, so this is the config file. This is the default. Okay, so currently I'm using this default. So I'm using the certificate. This certificate gives me access to the entire cluster. Okay, so now I'm going to do the same thing. I'm going to create a user. So I'll create a user. Okay, I'll create a user. I'll call it thread. And then the client certificate, I will put it in security workshop 03. This is the certificate, right? So this is the certificate. Don't put a CSR, right? The signed certificate. And then the next one that you want is the key. And so this is the thread key. Okay, so this user is represented by this certificate and this key. Okay, so now I will create a context. Okay, I'll create a context and I'll create a context here. So I'll delete all this. Okay, the namespace that I'm going to look at is workshop. The user I'm going to use is thread, and the name of this context is called workshop. Okay, so now I'm going to switch. I'm going to use kubectl to switch my context from using minikube to thread. Okay, and the way I'm going to do this is like this. So you go kubectl. You can go view. Config view. So that will show you the config, right? So that's the context. I've got two contexts, right? So there's thread and there's minikube. So I'll switch over to using the sorry, I think I made a mistake. Let me just go back. So the second cluster is called okay, so the second cluster is called workshop. Okay, so I'm going to change over to use this workshop. Okay, so I'm going to go kubectl config use context, and the context is workshop. Okay, so if I do this, so you notice immediately that I no longer have access to the resources. Okay, because currently that subject doesn't have is not bound to any role. So there is no access to any resource. So all this, I cannot see this. If I switch back to minikube context, okay, I get back everything. Okay, so now what I'm going to do is this: we will create a role. We'll call this the workshop operator role, and we'll give it access to only pod, to look at only pod and deployment. Okay, and nothing else. So I will go here and I'll now create a role called workshop operator YAML file. Okay, and what we want to do is this: we want to create a role. So we're going to use this. So we will say API version RBAC authorization. Okay, V1, and then kind is role. Okay, and then the metadata. So I'll call this the name. I'll call this workshop operator role. Okay, and this is namespace bound. I want it to be in this namespace. So I'll say workshop. Okay, labels. Let's this name. Okay, so that's just the permeable. So the next thing we will specify are the rules. Okay, so the rules is an array of a few things of API groups. Okay, there are other things I'll not talk about this. We'll talk about API groups. We'll talk about resources, and we'll talk about the verbs. Okay, so let me show you an example of how to get information on this. So if you open up your terminal, right, you go kubectl API resources, you go wipe. Okay, you'll notice that this is the name. This is the name of the resource. Okay, this is the name. This is the API version, and these are the verbs. What you can do. So if I want to look at say pod, right? Okay, so look at pod. The version. So the version is there's no preceding there is nothing, right? So it's the core group. Okay, and these are the actions that is available: create, delete collection, get, etc. Right? If I want to look at deployment, okay, so this is deployment. Notice the API group is apps. Okay, and these are the actions. Okay, so I want to give it pods and deployment. So what it will do is this. Okay, you go API groups, and then the core group is blank. So this is the core group. Okay, so API group. The next one is a list of resources, like this. Okay, so you can give pods. Make sure you spell it correctly. This one has S. Okay, pods. If you want to give services, you can also give services. Let me just show you services. So this is services, right? So services is also under core group. So you can do it like this. Okay. If you make a mistake here, right, Kubernetes will just happily deploy this. You will not really complain, right? So make sure you get the spelling correct. And then the third one is the list of actions. Okay, what are the available actions? And that's under verbs. By the way, you can also do like this, right? If you don't like this, you can do this way. Okay, you can go get, list, and watch. Okay, so these are the three essentially, things to do. Okay, so if you want to do if you want to give permission for deployment, for deploy, so it's deployments. Okay, the API group is apps. So we can do like this. So apps, this is the API group. This is deploy, what is it called? Deployments, DEPLOYMENTS, okay? And then the same thing again. So this is the role. Now we need to create a role binding. Okay, we need to create a role binding. So again, the same thing. I'm just going to copy this thing up here. Okay, so this is role binding. Okay, role binding. So let's look at role binding. Okay, so role binding again is namespace bound. So we will have the role reference. Okay, what role are we going to reference to? So the API group. This is the API group. Oops, V1, not V2. Sorry, V1. Okay, so this is the API group. Okay, so this is the API group. Okay, and then the second one is the kind. What kind is it? So it's a role. And then finally, the name is workshop operator role. Okay, so this three things refers to this thing up here. So the API version is this one. The kind is role, and the name, this is the name. So that's what it refers to. Oops. Okay. So the next one we need to say is the subjects. The subjects. So this is where you put your user, your service account. So again, the API group is the same as this. Again, if it is for user, if it's for user or group, you will just recognize. So you don't need to put the API group, right? So I'm going to skip this. The second one you need is the kind. The kind I'm going to say is the user. Okay. And then this is the important one, the name. This name is Fred. Fred here is the common name that we set just now. Is this thing in our certificate. Okay, so this is the name. Very important. This one must match the certificate. Okay, and the namespace in which we're going to use it in. So the namespace is workshop. Okay, if you've got others, for example, like if you've got more users, then you just put like kind, maybe service account. Okay, so name, my SA, right? And namespace, what namespace, right? Okay. So I've got this. So now I'm going to deploy this guy. Oops. I don't feel names. So it's name. Sorry, namespace, right? Let's try this again. Okay, so we have created the role and role binding. So let's go and have a look at it first before we do anything. Get role. So now we've got these two roles. Okay, we can now go and do the swap again. So we now use the workshop role, and if we do it correctly, notice that I can now look at the deployments and the pods, but not the secrets. Okay, let's say I want to look at the logs, right? So I can look at logs and go cube ctl logs -n. So workshop, right? Okay, so I don't have access to the logs. User thread doesn't have access to the logs. So this is the resource that I need. Okay, so let's go and fix this. Let's switch back to minikube. So I want logs, right? So I can give it this. What was the log, not S? Okay, like this. Apply this again. Okay, so now I switched over to workshop again. Okay, and then we'll look at the log. So now I can look at the log. Okay, so anytime when you got an issue with looking at something, so if I want to view, let's say I want to view the port from Cube system, okay, I'll get an error because I don't have the permission for Cube system. Okay, I only have permission. This user is only granted permission to view, to manage, you know, the namespace workshop. Sorry, the workshop namespace and nothing else, right? So you can play around with this and have a lot of control, especially if you've got a big cluster to manage. You create a certificate, you sign it, and then you just give the certificate and the keys, you know, to your user and ask them to set up the kube config. Then they can, you know, do whatever they want. Okay, so that is this is rollback. This is role-based access control. Okay, so we want to look at the last one, and I think almost out of time. It's 30 minutes. About 30 minutes more. I'm going to probably take about 15 minutes for this. The last one is network policies. By default, right, when you deploy a pod, it is like the Arc de Triomphe. You know, all road in Paris, you know, sort of leads to the, you know, leads to this the arc, the gate, and from the gate, you know, you can go almost, you know, anywhere, right? So this is the default pod access. Okay. So let me just very quickly show you an example first. Let me switch back to minikube first so I can do other stuff, right? Okay. So and so let me just show you by doing this. So what I'm going to do is this. I'm going to create a shell, and this will become important afterwards. So let me just remove some of these things. I want to look at something called network policy, and then I also want to look at network policy, and then I want to look at service, and I'll look at ingress. Okay, so I also want to show the labels. Okay, so what I'm going to do now is this. I'm going to create a shell. Okay, kube run. Let's call this shell. The image is Alpine. Then I want to restart because of never. And then I want PI. I want to remove. Okay, I want to have a label. I want to create a label. What I'm doing is I'm creating a container with a shell. Okay, let's call this. I'm going to label my pod as with the label shell, and then I'm going to run the ASH. While that's starting off, let me. Okay. Right. So now you made a mistake. I need to run it inside inside this namespace, right? Okay. Okay. So this is the shell. That's me here. That's a fortune, right? So I can actually do a curl to this IP. This is the internal cluster IP. I can do a wget. Okay, so remember the port is 5,000, right? So notice this is the fortune. Okay. So what I'm going to do is this. So let's go back to this. Okay. So the port allows anybody to access. That's the default access, right? In certain situation, what you would like to do is this. You probably sometimes, some examples that you want to control traffic is, you may want to allow, let's say like you're writing a multi-tenancy application, you're deploying like a multi-tenancy SaaS type of environment on your Kubernetes. You want to create namespace to represent your tenant, right? And you only want to allow traffic from the ingress controller to the namespace and from nowhere else. Okay, so this is one use case, right? So you want to isolate, and you want to manage the traffic, right? So you do not want you do not want ports from one tenant to be able to see ports in another tenant. So that would be disastrous, right? So that's one scenario. A second scenario where you might want to use this is in the case of microservices, right? So as you probably know, microservices, the idea is this, every service manage their own data. So in here, for example, I've got some port that accesses the MySQL database. So this is the MySQL database. These are the port accesses this, right? And I've got some external port which I only want to allow them to access via the service. They are not allowed to access the MySQL database directly. Okay, so if you've got a default deployment for your port, right, then you wouldn't be able to enforce all these things. Okay, so what we're going to do is this: we are going to create some rules to define some of this traffic flow. And the way we're going to use it, the way we're going to use this, the way we're going to do this is to use something in Kubernetes called the network policies. Okay. So again, by default, when you deploy pods are not isolated when they are deployed. Okay, this is the default policy. And the way network policy works is through whitelisting. Okay, so whitelisting basically means once you apply network policy to a pod, the network policy will close off all access, input, output, right? Ingress, egress, everything. And the way it works is you must explicitly allow access. Okay, so in other words, network policy, right, has only allow rules. It does not have deny rules. Okay, so once you apply a policy, everything is shut off until there's a rule to allow it. So you only have allow rules and no deny rules. This one, the idea is to prevent conflict. Okay, the rules are additive. Okay, so you add rules, you add allow rules, right? And the rules are evaluated using OR, not AND. That means they are not the intersection of the rules, they are the ORing of the rules. So if any rule in there allows the traffic to enter or exit, the network policy will allow it. Okay, it's not the intersection of the rules, right? It's the ORing of the rules. By default, the network policy, you need to install, to use network policy, you need to install a network solution or network plugin, right? Or CNI, something like Cilium, or Calico, etc. Otherwise, it will not work. Okay. I'm sure that if you use managed Kubernetes, all this is done for you. For example, like if you use DigitalOcean's Kubernetes, they're using Cilium. Okay. So what I'm going to do is I'll very quickly show you how to restrict traffic, ingress, egress traffic, right? And then after that, I will sort of, if there is time, maybe there's no more time. If there is time, I will show you how to define a rule, a network policy rule to only allow traffic from the ingress and nowhere else. Okay. So let me demo the just sort of like the basic concept for network policies. Okay, so what I'm going to do is this. I will now create a policy to deny all access. So notice here, right? I can access this and I can also ping. So from shell, right? I can also ping this guy, right? Okay, so from shell, I can also ping this fortune, right? So I'm going to create a rule to deny all access. Okay, and the way you work is like this: you go API version, networking, Okay, it's SIOV1. Okay, and then the kind is network policy. And then the metadata, I'll call this deny all. Okay, and this is scope, so I need to specify the namespace. Call this workshop. Okay. Labels, put that this thing here. Okay, so let's go and look at the documentation for this. Okay, yeah. Network policy. Okay, so we got a spec. So the way network policy works is like this. Okay, so I'm creating a rule. The rule is to be applied to a port. So you must first of all select a port to apply to. Okay, so using the port selector. Port selector. Okay, the port selector has got two ways of doing this. You can either use match labels or match expression, right? So we have seen match labels. Match expression allows you a greater flexibility in specifying an expression. So I'm going to use match labels. And I'm going to select this port. Okay, this port, right? So the label for this guy is name fortune port. Okay. So that's the first one. The second thing you need to say is the type of policies that's going to be in this rule. Okay, so it's either ingress, egress, or both of them. Okay, so policy types. Okay. So it's ingress. So I want both ingress and egress. So this one both control both the input and the output, right? So that's it. So there are no rules. So I'm saying that I'm saying that in this deny all, for this port, there is ingress and there is egress, but I'm not giving any rule. So these are the ingress. We'll look at this afterwards. I'm not giving any rule. So in other words, if there is no rule, it will shut off everything. Okay. So let's apply this guy. Okay. So once you have done that, we can look at this. Okay. We can go cube CTL. Describe netball deny all. So that's the name of the policy, and in workshop. Okay. So notice that this is a deny all policy. It is selecting this port, the fortune port, and allow traffic none. There are no rules for ingress, and there are no rules for egress. Okay. So now if we go back to here, this guy here, right? So I am this port, right? I'm this port, sorry, I'm this port, and I'm going to try to ping this guy, but this port has been shut off. Okay, so if I now do this, okay, notice that the traffic is not allowing any traffic in, and even if I try to ping it, okay, oops. Okay, there is no traffic, right? Now what happened is this: if I delete this guy, okay, notice that the traffic is now available again. Okay, so that's a very simple this is a very simple policy. Okay, so I've got a few more minutes. So what I'm going to do now is this. Okay, I've got an ingress installed. So that's my ingress. And what I'm going to do is I'm going to create this scenario. Okay, I'm going to allow traffic. I'm going to create a service. I'm going to allow traffic from the ingress into my namespace. But nowhere else can you access the application except through ingress. Okay, so let's do this. This is slightly more involved, and then we will end. Sometimes when I'm rushing stuff, it can go wrong. So if it does go wrong, I will promise I'll fix it, and then I will push the code up for you to have a look at it. Okay, so let's start by first of all creating a service. Okay, so I will create a service. What I'll do is this: I will just copy from here. So I'm just going to copy this in here. So this is going to be service, right? This is going to be service. Okay. So for the service, we need to specify the type of the service. So for ingress, you need to specify cluster IP. Okay, and then we need to specify the selector. So the selector, the name is just the Fortune port, right? And then we will specify the ports. Okay, so the port, this is the service port. So let's keep it the same. The service port is going to be 5,000. The target port will also be 5,000. Okay, so let's test this one first. Okay, let's have a look at the service. So I've got this service running, right? So now let's test the service by doing a port forward to the service. Okay, so we'll go service, Fortune service. The port forward, you go, the namespace is workshop. The target is 80 to 5,000. Okay, this is the service port, right? This is the external port. Again, if we run this guy now, it should now work. Okay, so the next thing we want to do is this: we want to create an ingress resource to direct traffic into here, right? So we will create an ingress. Again, let me just copy this guy. So the ingress is networking kas.io. Networking. Okay, so let me have a look. I cannot remember ingress. Okay, ingress here. Okay, so this is ingress, and we change the service ingress, and then we will go the spec, the ingress spec. Okay, so the ingress class name, I've installed the Nginx ingress, so the ingress class name is just Nginx. Ingress, okay, and then the rules. I'm not going to have certificate. You have rules. Rules. So rules is an array. We are not going to have a name unless you have a fully qualified domain, right? I'm going to leave this empty, so it's going to accept everything. I'm going to have an HTTP. Okay, and then the path. And then I have an array of path. Okay, so the path will be just slash. Okay, and then the path type is prefix, and then the backend is service. Is a service, and then the name of the service. The name of the service is Fortune service, and then the port is a number, and the number is 5,000. Okay, so that's the ingress. Okay, so this is a fake ingress because my ingress, I've deployed ingress, right? So this is my ingress controller. This is the external API. Okay, so this is the API. Currently now it's not showing anything because no application is deployed. Okay, so when I deploy my application and I refresh this, I should see my fortune here. So that's the ingress. Okay, so I'm going to deploy this guy now. Oops. Oh. Okay, so let's have a look at this. So I've got this ingress class defined. Okay, so I can use the kubectl engine ingress engine X ingresses from workshop namespace. Okay, so the ingress, the host, right? And that's the service that I route to. So hopefully, if I don't make any mistake, I'm now getting the ingress from here, right? Okay. So now what I'm going to do is this. I'm going to now define a network policy rule that only allows traffic from ingress to my ports and nowhere else. Okay. So in other words, if I try to ping from shell, it's not going to work, right? And just to prove the point, I will redeploy the deny all rule. Okay, so once I deploy that, right? If I now try to refresh cookie, refresh this guy, you notice that it's not getting the traffic. Notice this is still circling here, right? Because of the deny rule. But if I delete this, okay, you will notice that there's a timeout. So you notice that the traffic is available again, right? So I'm now going to define a network policy that allows traffic from my ingress. So let's go back to the networking. Okay, and oops. Okay, so I'm going to read the deny all topic here. Okay, so I'm going to create the fortune ingress. Okay, I'm going to call this fortune ingress. Okay, so we will match the port label, and now I only want the ingress rule, not egress rule. Okay, so let's go back to here. Okay, so I want the ingress rule. Okay, so the ingress rule is an array. Okay, so I want to go from where? Okay, so you can specify like an IP block, you know, and you use the CIDR to specify the range. You can specify from what namespace, okay, and from what port from that namespace. If you've got only namespace selector, then it's only from any port from that namespace, right? So I'm going to specify from what namespace, basically from the Nginx ingress namespace, and then from a specific selector. Okay, so let's have a look at this. So I want the namespace selector. Okay, the namespace selector is the same. It's just a label selector. You can either use match labels or match expression. Match labels. So I need to find out how to match this, right? So we can go kubectl get namespace, and you look at show labels. Okay, this is the Nginx. You need to know, right? You know what namespace you're working with. So this is the Nginx namespace. notice the network policy, right? To work with network policy, you need labels. A lot of us, when we create namespace, we don't have labels. So if you don't have labels for a namespace, it doesn't work. You need to go and create labels, right? So nginx labels. And so basically let's say I want to, there are two labels here. Let me just select this label. I want to use this label. Okay. That's one, right? So anything, any traffic from this namespace, the second thing I'll need to do is I'm going to select the port selector, what port from that namespace. If I don't say the port selector, any port can, I can receive traffic from any port, right? So I will go port selector, again, match labels. And we now have a look at what are the ports that we're going to get from this namespace. So I'm going to go port, show labels, and the namespace is ingress, nginx. Okay. I happen to know that this is the port that we're looking for, the controller, this port. Okay. And this is the labels. So notice that there is this label. This is the role, the controller. Again, you need to look at it because the labels, there are no convention to labels, especially when you're doing yourself. So you need to figure out what is happening. So this port can be selected with this label. They've got other stuff in there as well. So like nginx instance, etc. Right? So if you are really the Kiasu type, you only want the controller component from this particular namespace. You can do this. You can copy this guy. Okay. You say, so Kubernetes name, right? So it's here. Oops. So that's the Kubernetes name, right? So they happen to be use the same name. Okay. And I want this controller. Like that. Okay. To be more secure, okay, you can also say the port. That means traffic coming in from that namespace from that particular port can only go to a specific port in this namespace in my port, right? So this is the port you want. So you can say something here. Like this. So this is an array, right? So what port is port 5000. So this is your service. Is your service port 5000. So in other words, I'm saying traffic from this namespace or from this controller can arrive at this port on this port POD on this particular 5000 port. Okay. If you leave this out, if you leave the port out, then it can go to any port, right? Or if you leave the from part out and you just have ports, that means in other words, traffic from anywhere can come to this port, but only access it through port 5000, right? So there's a combination of these things. Okay. So now that we are done, we can deploy this guy. Oops. Ingress root got map expected array. So I think it's clear from. Okay. Okay. So let's have a look at the policy. The Oh, sorry. Let me delete all this one first. I made a to-do here. So this is network policy, net for. Okay, let me go and delete all this. Delete and reapply all this again. Right? Mistake, forgot to change. Okay, let me apply this again. Okay, so let's have a look at this. Fortune net port. Oh. Sorry. Okay, so let me change the net call. Okay, so I got net call. So finally, so let's have a look at this. Okay, so run that again. Okay, so sorry about that. So this is the network policy. We allow ingress traffic to port 5000 TCP. The selector is this ingress, and this is the port selector. Okay, so no egress traffic. This port cannot access third party, right? So if we go to here and we now try to ping it, we will not be able to ping. And hopefully, if I didn't do anything wrong, if you load this, we should be able to load this. Okay, so effectively, we have created a rule that only allows traffic from our ingress, right, and from nowhere else. Okay, so that is the end of my presentation. Thank you for your patience. The next time, sometime in May, we're going to talk about infrastructure as code, if you are into that sort of thing, and we're going to talk about declarative or imperative language, right? So declarative are things like your CloudFormation, your Terraform, your Ansible, your Bison, versus imperative are things like your Boto, your command line, your Pulumi. Okay, so we're going to talk about that. So this is next time. Okay, maybe in a month's time. Okay, so this is the end of my presentation. Thank you. You have stayed for a very long time. So I think I can open up to some questions. If you don't have, you can just probably leave. And I'll see you next time. Okay, thank you very much. By the way, I'll push the code up so that you can access the repository. The source code is available here. That's the repository. Once you can reach these slides, then you can get my repository. Okay, I'll push it after the session ends. Okay, so I'll end here. Thank you very much. If you got any questions, I can take some questions. Any questions? Any questions? Any questions? Any questions?
I think no questions from now.
No questions? Okay, if no questions, yeah.
Yep, don't see any. I think we can end the session.
Okay, so no questions, then I'll end the session. I'll see you next time. Okay, thanks. Bye.
Okay, thank you, Chuck. Thank you, everybody. Bye.